Okay, so today we're going to finish up section 6, and the notes are 1.6c. In this section, we're going to be seeing different forms of equations that we're going to be solving. Some of them will be cubed roots, some of them will be fourth roots. We're also going to introduce substituting a letter u into our quadratic equation to make our equation a little bit easier to factor. Now, remember, if you're going to use this u substitution, remember that after we solve and factor our equation with the letter u, we need to remember to substitute it back and get it back to its original variable. And we're going to see this. The other thing that you need to remember back from the review chapter is that when you have a fraction exponent, anything raised to the 1/2 power is really just saying the square root of that number. Or if it's raised to the 1/3 power, that's the same thing as saying the cubed root. Yes?
Are there only going to be fractions with half and thirds?
No, there'll be other fractions. But just realize that the denominator tells you the root. Okay, we're going to see some with like 2/3 or 2/5, things like that. Yes?
Would that mean that if it's 2/3 that it would still be a cube root?
Yes, and we're going to use the u substitution on that. So we'll be doing a cube root with that, and then we're going to substitute in the letter u to make it a u squared. So we're going to see how it works. Okay, so let's go ahead and see our first one. This one's pretty basic. It's very similar to the square root part of 1/6 that we did. Remember when I taught the square root section, that's where I told you the first step is to isolate the radical. So I need to get one of my radicals here on one side of the equation. So what I'm going to do is I'm going to move this one to the other side. So I'm going to add the cubed root of x to the other side of my equation. So now I have this one. They're actually both by themselves, but they're on separate sides. And now, just like when I solved the square roots, my second step is to raise each side to a power that's equal to the index. So here my index is a 3 because it's a cubed root. So I'm going to cube both sides. Remember, cubing this radical sign cancels it. And remember when we did the square root, squaring a square root canceled away the radical. So now what comes out of this is 4x squared minus 4x plus 1 equals x. I now need to get this into standard form so that I can either factor it or use quadratic formula. Now, I could also do completing the square if you prefer that method. Right now at this point, after I move that x over, I'm going to use one of the techniques in lesson 4. And that's what you did on the test yesterday. So 4x squared minus 5x plus 1 equals 0. I'm going to factor it. For me, factoring is faster. However, you can also do quadratic formula, and you could also use completing the square. So this trinomial will actually factor into 4x minus 1 and x minus 1. So the factors of 4 are 4 times 1, and the factors of positive 1 are negative 1 times negative 1. Now that I factored the trinomial, I set each equal to 0. So 4x minus 1 equals 0, and x minus 1 equals 0. Going to add 1. 4x equals 1. Divide by 4, and I get x equals 1/4. Over here, let me finish up this one, and I get x equals 1. Notice none of them are negative. You should check them, but they will both check out. So as long as you have an odd root and there aren't any negatives to eliminate, they're both going to work. If it's an odd root, even the negatives will work. It's only when it's a square root and you have to test out the negative to see if it works. Because sometimes the negative works, sometimes it doesn't. But this is a cubed root. A cubed root is an odd number, so even if it's negative, it will work. All right, so the next example, we're going to use the U substitution. Because on this one, if I try to factor this, I can't come up with a factor. It's not factorable. So what I'm going to do is I'm going to substitute the letter U for my middle variable here, my x squared. So I'm going to let U represent the variable x squared. So now I'm going to substitute. So this will become an negative 11U. I'll rewrite this. And then I'm going to also replace the x to the fourth with U squared. And now I have something that's factorable or more manageable. So the factors of 12 will be 3 times 4, and the factors of 2 are negative 2, negative 1. I now set each equal to 0. I'm going to solve for U. I'm going to add 2. Divide by 3. I get U equals 2/3. I'm going to solve this one. Divide by 4. And U equals 1/4. Now, at the beginning, I had that caution. Remember, in my original equation, I didn't have the letter U, I had an x. So we're solving for x. So now that I found the value of U, I'm going to take both of them and plug it in to what I set U equals. So I take my U equals x squared, and I'm going to take what U equals and put it here. So now I get x squared, I'm just going to flip it around, equals 2/3. Over here I'll do the same thing. X squared equals 1/4. And now I have to solve for x squared. So here I'm going to square root both sides. And I get x equals plus and minus the square root of 2 over the square root of 3. Now, I can never ever leave a radical in the bottom, so I need to rationalize. So I'm going to multiply the top by square root 3 and the bottom by the square root of 3, giving me square root of 6 over 3 plus minus. Over here, same thing, square root both sides. X equals plus and minus the square root of 1 over the square root of 4. Those are both perfect squares, so plus and minus 1/2. This is just a trinomial, so I don't need to do the check. So these are my solutions, no radicals. Again, I've got something crazy here. I'm going to do a U substitution so it's more manageable to factor. I am going to let U equal this middle term. And the middle term is x plus 1 to the 1/3 power. Notice over here, my first term, so this just becomes minus U minus 2 equals 0. This one, the 2/3, when I multiply it by the 1/3 for the substitution, or when I raise it, it's going to cancel. The 2's are going to cancel. Wait a second, let me erase that. Now the factors of negative 2 that give me negative 1 are going to be U minus 2 and U plus 1. I now will set each one of those equal to 0. And I will solve for u. And now I need to substitute it back to figure out what x equals. So u equals, so 2 equals x plus 1 to the 1/3 power. Over here, -1 equals x plus 1 to the 1/3 power. Remember that 1/3 power is like a cubed root. So in order to solve for it, I'm going to cube both sides of my equation. Power to a power, you're multiplying the 1/3 times the 3. So this becomes a 1. This side, I actually have to figure it out. 2 to the 3rd power is 8 equals x plus 1. Subtract 1, x equals 7. Over here, -1 to the 3rd power is -1. Move the 1, x equals -2. Again, it was a cubed root, so they're both going to work, even the -1. 6 equals x to the 4th. I now need to get this into standard form so I can try to factor this. I'm going to move them both at the same time. So then I get x to the 4th minus 5x plus 6 equals 0. And I think I need a square here. Okay, so now at this point, if you wanted to do a u substitution, you could, but this really isn't that difficult to factor. I can find the two factors of 6 that will give me -5. And that's going to be -2 and -3. So I just, instead of an x, I've got an x squared minus 3 and an x squared minus 2. The only time you're going to do that u substitution if it's just something unmanageable and you want to make it easier to factor. If you can factor an x to the 4th power, then do it. Just split it into x squared times x squared. Because you can square root an x to the 4th. So now I set each equal to 0. And I will add the 3. Over here, I'll add the 2. And then to solve this, you square root. And you get x equals plus and minus the square root of 3. And here you get x plus and minus the square root of 2. Now, notice in my original problem, I was trying to find the 4th root of this thing and make it equal a positive x. Okay, when we plug this in, when I do a 4th root of something, I'm never going to get a negative number. So in that particular case, I can just see the obvious that I'm going to throw away the negative solutions. So this one, square root of 3 positive and square root of 2 positive. Here, it's sort of like the square root. So it's already isolated. To get rid of those radical signs, I just have to raise both sides to the 3rd power. That will cancel the root. And then I'm left with 2x equals 5x plus 2. I now need to solve for x. So I will move the 5x over and get -3x equals 2. Divide by -3. And I get x equals -2/3. Again, it's a cubed root, so the negative will work. Number 6 is the same thing as number 1, but it's already set up for you. Actually, it's the same thing as number 5 also. It's already separated. So we've done some of these before. All we have to do is to get rid of the radical, raise both sides to the third power. And I'm left with 3x squared minus 9x plus 8 equals x. I now need to get it in standard form. Move it over. And now I need to either factor it or do the quadratic formula or completing the square. Again, for me, if it's factorable, that's the fastest thing because then I don't have any radicals to break down. But if it's not factorable, then you have to resort to completing the square or quadratic formula. Does that make sense? Now, let's see, I think we have time. Do you want me to show you a different method other than factoring, or are we good with the factoring? We're good with the factoring, and let's just keep factoring. All right, if there's time, I'm going to go back and I'll solve it with completing the square. However, this is factorable, so 3x minus 4 and x minus 2. Because if you FOIL it, it will go back to your original trinomial. So here I'll set 3x minus 4 equals 0, x minus 2 equals 0, add the 4, 3x equals 4, divide by 3, x equals 4 over 3. Here add the 2, and x equals 2. So there's your solutions. Number 7, same thing, except for we have fractions. But again, remember, when you have a rational exponent, it's like finding the root. So this is finding the cube root. Step number 1, isolate it. So I'm going to move this one to the other side. And then I get 3x plus 7 raised to the 1/3 power equals 4x plus 2 to the 1/3. Again, get rid of the 1/3 power by raising it to the third, because 1/3 times 3 is 1. So then this comes out, 3x plus 7 equals 4x plus 2. Group your like terms. I'm going to move the 3x over. You could move the 4x, it doesn't matter. I'll add the 2, or sorry, subtract the 2, and I get x equals 5. Yes?
What was the plan for bringing it on the other side? Didn't you just do it if it was all on the same side?
No, you have to isolate it. So that's always step number 1. So you have to get either one of the square roots by itself or one of the parentheses raised to exponent that's a fraction by itself. That's always step 1, to isolate. And then from there you can start the solving process. Number 8, same thing. So all we have to do is raise both sides to a power equal to the index. My index is 4. So I'm going to raise both sides to the 4th power. Cancels the radical. 3x plus 1 comes out. 1 to the 4th power is 1 times 1 times 1 times 1, which is 1. Subtract the 1. 3x equals 0. Divide, and x equals 0. X equals 0 is a valid solution. Yes. Isolated. All we're going to do is raise both sides to the 4th power. Cancels. And I get x squared plus 6x 2 to the 4th power is 16. I need to get this into standard form and check to see if I can factor it, which I can. Factors of negative 16 that give me 6 are going to be positive 8 and negative 2. Set each equal to 0 and solve, and I get x equals negative 8 and x equals positive 2. When I do substitute in that negative number into the 4th root, it does work. This one's kind of manageable to do. If you do negative 8 squared plus 6 times negative 8, we're going to see if that 4th root equals 2. This gives me 64 minus 48, which gives me the 4th root of 16, which is 2. So that negative 8 does work on this one. Again, same thing, except for instead of a radical sign, we're raising that thing to the 1/4 power. But we get rid of it the same way, and we are going to raise both sides to a power of 4, because 4 times 1/4 gives me 1. So 3x squared plus 52x equals 256. I now need to get it into standard form. So I'll subtract the 256. 3x squared plus 52x minus 256 equals 0. At this point, you could do completing the square, quadratic formula. Again, it's factorable. So factors of 3, I'll use 3 and 1. And then factors of 256 are actually going to be 64 times negative 4. I know that's a really big number, but it is factorable. It will FOIL back. So now I'm going to set each equal to 0. So 3x plus 64 equals 0. X minus 4 equals 0. Solve them. Subtract. So x equals negative 64 over 3, and x equals 4, and they check. So I will add 3 here and get 2x squared equals 3. Divide by 2. X squared equals 3 over 2. Remember, to solve for an x squared, we square root both sides. So I get x equals plus and minus the square root of 3 over the square root of 2. I can't leave a radical in the bottom, so I need to rationalize. So I will multiply the top and the bottom by the square root of 2. Giving me final answer, square root 6 over 2. Over here, I'm going to add the 1. 2x squared, divide by 2. X squared equals 1/2. Square root both sides. And I get x equals plus and minus square root of 1 over square root 2. I could actually square root the 1, becomes 1, but I got to rationalize that bottom. So root 2 over root 2 gives me square root 2 over 2, plus minus. So final answer here, plus and minus square root 6 over 2, and this one plus and minus square root 2 over 2. It's a trinomial, we didn't need to check it. Number 12, notice I've got a 2/5 power and a 1/5 power. What I'm going to do here is raise both sides to a power of 5. Because this radical, if you think of this as 4x to the 5th root, it's already isolated. So I'm going to raise both sides to a power of 5. This just becomes a 4x because this becomes a 1. This, when I multiply it, becomes an x minus 3 squared. I need to FOIL that left side. Because remember, x minus 3 times x minus 3 is x minus 3 squared. So then it becomes x squared minus 6x plus 9 equals 4x. I now need to put it in standard form. So I'm going to move the 4x over. X squared minus 10x plus 9 equals 0. I need to find two numbers that will multiply to give me 9, but who will add to give me negative 10, and that is going to be negative 1 and negative 9. I will now set each equal to 0. And I get x equals 1 and x equals 9. This one. Again, I have, you can think of this as like a square root. So it's already isolated. So I'm going to raise both sides to the 4th power. That cancels that, so I get x. I have to raise the 3 also to the 4th power, so that actually gives me 81. So 81 x to the 3rd, because when I just did it to that, it just becomes x cubed. And then over here, this becomes an x squared. I now need to get it into a form that I can factor. I'm going to move the x squared over, set it equal to 0, and I'm going to factor out a GCF. My GCF is x squared, so 81x minus 1 equals 0. It's not a trinomial, so I just set each of the factors equal to 0. So first that one, and now this one. For the x squared, when I try to square root that, it's just x equals 0, no plus minus. Here I'll add 1. 81x equals 1. Divide by 81. X equals 1 over 81. So my solutions are 0 and 1 over 81. And one more example, we're going to go back to the U substitution. Ready? Here we go. So if I try to factor this trinomial, it's kind of challenging. So instead, I'm going to let U equal this middle term. So U is going to equal 2x minus 1 to the 1/3 power. So now I can change my equation to say u squared plus 2u minus 3 equals 0. Just become u plus 3 and u minus 1. Set this equal to 0. Set this equal to 0. Subtract 3. Add 1. And now I plug it back in. So negative 3 equals 2x minus 1 to the 1/3 power. And then the next one is going to be 1 equals 2x minus 1 to the 1/3 power. First thing I'm going to do is get rid of that 1/3 power. by raising both sides to a power of 3. So then I get negative 3 to the third power is negative 27. The 2x minus 1 comes out. Add 1. Negative 26 equals 2x. Divide by 2. Negative 13 equals x. 1 to the third power is 1. Drop out the 2x minus 1. Add the 1. 2 equals 2x. Divide by 2. X equals 1. So x equals negative 13 and x equals 1. Again, it was a cubed root, so we don't have to worry about the negative. Homework is 51 through 71.